Good morning, everyone. I'm Brock. So today, let's walk through a LeetCode quiz together again. So this question is maximum number of moves in a grid. You are given a zero-indexed M multiply N matrix grid consisting of positive integers. You can start by any cell in the first column of the matrix and traverse the grid in the following way. From cell row call, you can move to any of the cells. Row -1, call +1. Row, call +1, and row +1, call +1. Okay. So the basic idea is to move 3, either go right, go down, or go right and down, such that the value of the cell you move to should be strictly bigger than the value of the current cell. Return the maximum number of moves that you can perform. Okay. So because we need to find the maximum, right? So which means that we actually need to try all the possibility. So if the input grid is such a thing. So you see, visualize is always a good way to help us to understand a concept. And we start from cell 0 and go right down, go right down, and 11, and then we're done. So it's but why it doesn't go one more step down? I think that it can also go to 15, right? Wait, it should also be able to go to 15, right? It's also, bigger than the current cell. Why 15 doesn't work? Oh, wait. Row -1. Oh, go to the right above. Okay. Oh, okay. I got you. So the way it can go to is right above, right bottom. So 3 options, which means that it's always go forward. It's just like a Chinese chess, right? The soldier can only go forward or move horizontally, which means that since the grid it has 4 columns, so it at most is 3, right? So it's impossible bigger than 3. Okay, let's see the second example. This is a grid. It's 0 because because for the fourth column, for 3 we cannot move, for 2 we cannot move, for 1 we cannot move, so it doesn't work. Okay, I guess I understand what we need to do, what we need to do now. And Again, let's start from a specific case and then try to generalize into a more normal situation. So let's start by a case, specific test case. Let's still create a grid first. Let's say make it 3 rows. And make each row has 4 columns, okay? Okay. So, step 1. What do we need to do? We need to, so, okay, and it's great. We need to know the length of the grid, right? At this situation is 3. Which means it's this is about the rows. And also we need to know how many columns it have, right? So now we need to know the columns. Step 2. We need to initialize a table, right? Because we want to store the maximum thing. So we need to use dynamic programming. So we need to initialize dynamic programming DP as a 3 multiple 4 table, right? And to begin with, we can fill the table with -1, means uncomputed. Okay. Next step, we need to call DFS for each row in the first column. In this case, will be df00, df01, dfs02. Right. And then we need to so this is like a help function. So helper, right? Let's say DFS 0, 0. The current value is 1. The current value, okay. The current value is 1. And then we need to check its label, right? Which is row minus 1, column plus 1. In this case, it will be minus 1. 2, obvious invalid, right? And another label, row C plus 1, it will be the same row, 0, 2. No. Will be 0, 1. Okay, will be 2. This is good. So yes, this is valid. If this is valid, we will go to recurse, right? And keep try its labels. Row plus 1, column plus 1 would be 1, 1. And 1, 1 will be 2. Again, 2 is valid. And if 2 is valid, let's do recurse, right? And step 5. Stimuli use DFS, which is depth first search. We use DFS. We explore its labels until it gets to column 3, right? Explore its labels to get to column 3. Makes sense? Because it has 3 columns in total, or 4 columns in total. And each successful recursion returns 210 moves. Right? Because DFS 01 already in the second column. So for each recursion, right? It's either 2 movements, 1 movement, or cannot move, which is 0. And after recursion, EP 01 is equal to then DP 00 will become 3. Right? Because literally it's just add one more step or one more movement here. And step 6. After we calculate all stars in first column, because anyway, we only have m possibilities to start with, right? So you see, no, n, it only have n columns anyway. So the max, we need to calculate the max across dp 00, dp 10, dp 20, right? And we needed to calculate dp30 because it's the last one anyway, right? Which is 3, return, right? I think this is one case, you know, how we want to calculate the solution. So from one situation, we want to initialize to a more general situation. And our input is a grade, which is list int. Our return type is int. Okay? So based on the strategy we talk about, firstly we need to figure out what's the length of the row, right? And if so, if the grid is empty, always think about the edge case, right? Then we just return 0. Right? If not, let's continue. Let's check. Let's check the length of the rows. No, columns. How many columns we have? And then we need to initialize the DP, dynamic programming. So we want to create a DP table with -1, right? For uncomputed values. And the DPRC will be used to the maximum value from RC. So in this case, it would be just a loop, right? Everything in range M. So -1 for everything in range N. That's N columns. Okay. Then we may want to define all allowed label row offsites relative to current row, right? Because you either go up, stay in your row, go to next row. So the direction will be -1, 0, 1, right? Upright, right, down, right. Okay, now we need to define the recursive DFS, depth first search. Okay, so let's get such a help function. So we need to have two values, row and column. Both of them will be int. Okay. And if DP already computed for this cell, return it, right? Check the edge case always. So if dp rc is not equal to -1, then we just return dprc, right? And then we need to initialize a best move. From current cell to 0. Right, because we haven't made any move yet. And we need to initialize a current cell value. Initialize current cell value, which is current value grid RC, right? Because we need to use it to compile the value later. So now, what do we need to do? We need to iterate through, it through allowed directions to check potential moves. For direction, we need to row will go in, 3 possibilities. And column just move on. And we need to check the row, right? The row must be inside the boundary. So check row or label row must be within what? 0? M minus 0, right? And label column must be within 0, n minus 1. Make sense? Okay. So if neighbor row is smaller than 0, what happened? Nothing, right? We just skip it. And if neighbor row is larger than m, what happened? Right? It's also go out of the boundary. So continue. And what if n, the label column is larger or equal to n? What happened? If label column is larger or equal to n, then what happened? Again, it's also go out of the column, right? Okay. Then we need to compare the value. Now, okay, now we ensure that it's inside the boundary. So now we only move to neighbor. if value, right, is larger than label, than current, if label larger than, so if grade, the label larger than current value, if label is larger than, which means that it's safe to go to this label, right? So we will recurse to compute maximum moves starting from the label, which means next move will be DFS, label column, label row, label column, right? Make sense? Then right, if we can move to the label, we have actually 1 plus, right? Whatever moves the label have, which means the candidate will be 1 plus next moves. But because from here to move to the label, we will have 1 step. Okay. Then update the best, right? If candidate is larger than our best, then we give candidate 2 best. Make sense? And then we need to put best in the DPRC. Again, I think that it's hard to say, which column DPRC. Yeah, it's hard to say the indentation. Then return best. Right? This is a DFS. Okay. After we finish the DFS, we need to compute the result, right? Result is a path, so we need to start from every cell in the first column and find and try the max. Search the maximum. So with result start from 0, and iterate through all rows in the first column, right? Iterate through all rows in the first column. So for row in range M, right? Column M is what? Okay, M is how many rows? Okay. Again, edge case. Only attempt DFS if there is more than one column, right? Because if just one column, then it's 0. So if n is equal to 1, then jump out of the loop. But if n is not, then what do we need to do? We need to call DFS for cell at row 0 and update the global results, right? Or DFS for cell at row 0. So moves from current cell to DFS. Right? What's your role? 0. Okay. And if moves from cell larger than result, then what we do? What are you doing? Then we just make moves from cell become our result, right? and then we just return result. I'm not sure. Okay, I guess I shouldn't define the output. Yeah, the arrow is at okay. I guess that the arrow is that I cannot define the tab of the parameter. Output is none. How it could be? And it's not even 0. It's none. What does that mean? It means we don't have any return. I think that the issue came from the indentation, but sometimes I really feel confused about the indentation. I don't know. Yeah, I assume maybe there's some issue with the indentation. Code bug. But most of the time, right, when we do a technical interview, the interviewer won't ask us to be able to run the code. So indentation is, may not be a, I think Python code actually can easily get the wrong indentation for Python code. How do you avoid that? Yeah. Okay, so the first issue is early return inside the loop. Is indented inside loop, so you should return after check the first iteration. DP best. DP best. Early return. So does that mean I should go to be here? Let's try to run it first. Nope. 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 List index out of range. If grained larger than current value. And the arrow is list out of a range. Row bound check off by 1. Larger than M. Continue. Okay. Oh, accepted. Interesting. Yeah, accepted. The time complexity. Submission length exceeds limit. Interesting. Cannot analyze the complexity. Okay. Interesting. Yeah, so Python's white space sensitivity make indentation bugs both common and sneaky. Here's a clear and practical guide. Firstly, understand why it happened. Python uses indentation to define code block instead of how to pronounce this one. Brackets. Curly braces. Open curly brace, close curly brace. Okay. A single misplaced space or tab can change the block structure. Copying code from browser can also mix tabs and spaces. Always use spaces, not tabs. Okay. Use 4 spaces per indentation. Okay, turn on visible indentation get. Show web spaces. Use a liner or formatter. When you are about incorrect indentation, check indentation in your editor. If you return line for together with the for loop is wrongly indented. Use a line-friendly test sleeper. But what if I'm editing, writing Python code in, let's say, I falsely use curly brace in Python, just like C++. No, you cannot use curly brace. Why it doesn't allow it? The indentation defines block. If you try to write curly braces, you will get error. Okay, curly braces is for other meaning. Python's indentation rules prove readability, enforce consistency across projects, prevent dangling else. Okay. White space significant language. Okay. Okay. Yeah, I guess that we don't have some workaround way to solve this issue. So it looks sad at this moment. The only thing is that remind myself, to have the right indentation. Yeah, I think that's pretty much for today's LeetCode question. Thank you, everyone. Bye.